Hello, good morning, everybody. I hope you are all doing well. Okay, today's lesson will be starting a new section in the 15th chapter, that is segment relationships in circles. So today's class will be about three theorems related to some segments that are in circles. Let's start by the first theorem. We call it chord product theorem. So basically, what is a chord? It is a segment that is inside a circle. Okay, it crosses the circle in 2 points, like this one. CD is a chord, and it doesn't pass through the center. So AB and CD are chords. Okay, obviously in Arabic we say water. If two chords intersect inside a circle, then the products of the lengths of the segments of the chords are equal. The first theorem says if I have two chords that cross each other inside a circle, okay, then this equality holds. So AE times the length EB equals to the length CE times the length ED. Okay, this is the first theorem. Let's do some applications. I have this circle and I have two chords AB and CD. Now I want to find the length, that is X, and to find the length of these two chords. So applying the chord product theorem, we first solve for X. So what is the theorem saying? It says CE times ED is equal to AE times EB. That's what we wrote here. Now CE is 6 and ED is 2. Okay, this is ED2, and EB is 3 and AE is X. So AE times EB is 3 times X. Very good. Now I have an equation with one unknown. 6 times 2 is 12, 3x. So x, just by dividing both sides by 3, and x is equal to 4. Now are we done? Not yet. We just found x, and we need now to find the length of each chord. Very easy. Now we know that the length CD is equal to CE plus ED, that is 6 plus 2, which is 8. That's for CD. Now for AB, it is AE plus EB. AE is X, which is found to be 4. EB is 3, so 4 plus 3 is 7. So AB is 7. All right, let's do another application. I have these two chords here, IK and HG. They intersect in the point G here. All right, now what will be the length of my chords? So first I start by setting up the equations from the chord product theorem. So HG times GJ, okay, this is J and this is G, make the difference in between, GJ equals to KG times GI. Okay, now I'm going to substitute with the corresponding length. HG is 9, GJ is 8, equals to KG, that is 6, and GI, which is X. Okay, we solve this simple equation. 8 times 9 is 72, equals to 6x. Divide both sides by 6, then your x is 12. Now in order to find the length of your chords, you substitute. For Ki, you have Kg plus Gi, that is 6 plus x, that is 12. So 6 plus 12, that is 18. That's for Ki. Now for Hg is already there, so it is 8 plus 9, that is 17. Easy theorem. You just plug numbers and solve. Okay, let's take another example. Given AD equals to 12, this total length is 12. Find the value of x and the length of each chord. Okay, so let me set up the equations for the chord theorem. We know that AE times ED equals CE times EB. Very good. Now, AE is given to be 3. What is ED? It's not given. How can I find it? I have AD, that is 12. So ED is 12 minus 3, which is what? 9. Okay. Now the other side, CE, which is X, and times EB, that is 14. Very good. 12 minus 3, that's 9. 9 times 3, that is 27. Okay. Equals to 14x. Okay. Now x is 27 divided by 14. Well, to be honest, if you have a general question, it did not ask to make approximation, I don't like this kind of answer. So you just keep it as a fraction. Just simplify the fraction, keep it as it is. I don't like this. Unless it's mentioned. If I mentioned here, make approximation, then yes. Otherwise, no approximation, please. So x is equal to 27 divided by 14. Okay? Now, what is CB? It is x plus 14. That is 27 divided by 14 plus 14. You simplify, also write it as a fraction. And AD is already given 12. Alright? Now let's check another theorem. Okay, before going to the theorem, I need to define something. What is the secant? Okay, secant is different than the chord. We know that the chord is inside the circle. The secant, okay, it goes outside of the circle. It's like this one. So it comes from outside of the circle and it crosses or intersects with the circle in 2 points. For example, we say EA is a secant. So it comes from outside, then it intersects the circle in 2 points. Here are A and B. Also, EC is called a secant. Secant in Arabic, we call it qati'. Okay? So, the secant product theorem, it says in a circle when you have 2 seconds that intersect outside the circle, then you have AE times BE equals to CE times DE. So the total multiplied by the external segment equals to the total multiplied by the external segment. Okay, so this is the secant product theorem. Let's do some applications on that. So I have, this is my circle. I have these 2 segments. They are what? They are seconds because they are coming from outside. They are crossing my circle in 2 points. Okay. Now I need to find the length of each second. So first I need to set up my equations, find x, then substitute to find the seconds. That's what I'm going to do. So the secant theorem says total AC multiplied by the external AB equals to the total AE multiplied by the external AD. That's what I did here. Now, what is AC? AC is 5 plus x. What is AB? The external is just 5. Now, what is AE? It is 6 plus 6, which is 12. What is AD? It is 6. Okay, you simplify your equation. That is 5x plus 25 equals to 72. Okay, subtract 25 from both sides. So gives you 5x equals to 47. Divide both sides by 5. Okay, and x is 9.4. Okay, in this case you can write it as this, or you can write it as a fraction. Okay, now add the segments together to find the length of each second segment. Here we just found x, so we need to find each second segment length. Okay, so AE is already given 12. Now what is AC? It is 9.4, that is x plus 5, which is 14.4. Okay, let's take another example. Set up an equation. So we need to find the length of these seconds. So we know that SP times RP equals to UP times TP. Okay, now UP is 7 plus X, TP is 7, SP is 8 plus 6, which is 14, and RP, it is 6 here. You simplify the equations, very easy. So this simplifies to 7x equals to 35, divide by 7, then this is 5 as x. Now, the length of my seconds, this is already given to be 14, and the length of UP is 5 plus 7, which is 12. Very easy. Okay, finally, let's finish up with this theorem. It is called secant tangent theorem. So we had chord theorem, we had secant theorem, now we have secant tangent theorem. Okay, now in this circle, AC is a secant and CD is a tangent. Remember what the tangent is? Okay, this line or the segment tangent is coming from outside and it touches my circle just in a single point. That is the tangent. So CD is a tangent, whereas AC is a secant. Why? Because it crosses in 2 points, not one. Okay, so the theorem of secant to tangent says, in this example, AC times BC will be equal to your tangent segment squared. So the external or the total of your secant multiplied by the external segment of my secant, that is BC, will be equal to the square of my tangent segment. AC times BC equals to DC squared. Okay, let's do some two applications for this theorem. So given the diameter of Earth that is 8,000 miles, suppose this is the Earth and it has a diameter of 8,000 miles. Okay, a satellite's orbit is 6,400 miles above the Earth. So SE here, this length SE is 6,400 miles. Now, I need to know the distance that is SP, or the distance from the satellite to the pole. Okay, so what is this distance? I labeled it X. So this is my tangent segment. This is my secant. It crosses my circle in 2 points in E and A. So the tangent or the secant tangent theorem says AS times ES equals to SP squared. That's what I did here. Now SA is what? Is the diameter plus the distance above the Earth. So it is 8,000 miles plus 6,400. Okay, and SE is of course above the distance above the Earth, that is 6,400, equals to x squared, which is the unknown. Okay, we simplify our equation. 8,000 plus 6,400 gives you 14,400 multiplied by 6,400, which is equal to x squared. You multiply these numbers and this gives you 92,160,000. Okay, equals to x squared. Now, to find x, of course, I'm going to square root both sides. So the square root of x gives you x. The square root of this number gives you plus minus 9,600. Remember, the square root always gives you two values, one negative, the other one positive. But now, since we are measuring distance, of course, we know that the distance is a positive number. So we are going to discard the negative one and take the positive one. So we say the distance x, or the distance SV, is plus 9,600 miles. Final example. Suppose you are in a trip in the wood, okay? You moved along this path 100 yards, okay, and you are now standing here to observe the nest of the hawk, which is x distance far from you. Okay, this is a circle. The nest is exactly around the circle here, and you are standing at this point, which is 25 yards away from the circle. Now, if the path that you have passed, which is from the tangent here to the point or the lookout station where you are standing now, is 100 yards, what will be x? So here you simplify your problem. You say that this is a tangent segment, which is the path from this point to the lookout station, okay? And the point from the lookout station to the nest of the hawk is a second. Very good. Now let's set up our equation. So it will be x times 25 equals to the segment tangent squared, which is 100 squared. So x times 25 equals 100 squared. Now 25x equals to 10,000. Divide both sides by 25 and your x is 400. So the nest of the hawk is 400 yards away from you where you are standing here. Okay, very easy theorems for today. Thank you so much for following today's session. Okay, let's see each other in the next class. Okay guys, don't forget to check your classroom. I'll be uploading quizzes and homeworks there. If you have any question, feel free to contact me. Okay guys, take care of yourselves and see you tomorrow. Bye.